All right, let's dive right in. Today, we're tackling a really radical new idea about how our own minds work. We're going to take a look at something called the relativistic brain.
So you've probably heard this a million times, right? The idea that your brain is basically just a computer made of meat. It's a super common way to think about it. But what if that whole analogy isn't just a little bit off? What if it's completely fundamentally wrong?
You know, for decades, this has been the holy grail for science, for both neuroscience and AI, the dream of perfectly simulating a human brain on a computer. It's this idea called computationalism, and it's all built on the assumption that the brain is just a machine we can map out, understand, and then reverse engineer. But what we're digging into today is a theory that says this whole dream might be built on a massive mistake.
Okay, so to really get why this is such a big deal, we have to go back to the beginning. We need to understand this digital brain dream. Like, where do we even get this idea in the first place?
It pretty much all comes down to this thing called a Turing machine. Now, this isn't some clunky old machine sitting in a museum. It's a theoretical model from way back in the 1930s that is the foundation for, and I mean this literally, all modern digital computers. And the key thing to get here is that it follows a fixed set of rules, an algorithm. And there's this really clean, hard line between its physical parts, the hardware, and the program it's running, the software.
But here's the thing. The moment you try to put that Turing machine model next to an actual human brain, well, the whole comparison just starts to fall apart. Think about it. A computer's hardware, it's fixed. It is what it is. Your brain, its connections are constantly changing, rewiring themselves. That's plasticity. A computer's logic can be run backwards, but you can't just unform a memory in your brain. That process is irreversible. And maybe the biggest difference of all, a computer crunches abstract symbols, just ones and zeros. Your brain deals with rich, messy, contextual meaning.
So right away, we're starting to see some pretty serious cracks in the foundation of this whole brain as a computer idea.
Let's think about how scientists even try to simulate something biological. What do? First, they take messy, complicated reality and they try to smooth it out with clean mathematics. Then, they take that math and boil it down into a computer algorithm. See the pattern here? The key word in all of this is approximation. With every single step, you're getting a little bit further away from the real, living, breathing thing you were trying to model in the first place.
And this points to a really deep problem that the mathematician Henri Poincaré was talking about over 100 years ago. He basically said, you can't figure out what a complex system is going to do just by looking at its individual parts. And when it comes to the brain, man, the whole is so much more than just the sum of its neurons.
Okay, so this brings us to the first huge crack in the theory, something called non-computability. And this isn't some fringe idea. This comes from computer science itself. All it means is that there are certain kinds of problems that are mathematically impossible for any algorithm, any computer program to ever solve. It just can't be done. Think about those gut feelings, those intuitive leaps, or a sudden flash of creative genius. How do you write an algorithm for that? It just doesn't fit into a neat step-by-step process.
Want a real-world example? Just look at this number. That is the estimated number of ways that a single, fairly simple protein can fold itself. Your body's biology solves this problem, it finds the right shape, in milliseconds. But for a normal computer, this is what they call an intractable problem. If you tried to make a computer calculate all the possibilities, it would literally take longer than the age of the universe. And yet, your brain, your biology, it does this kind of thing all the time, without even thinking about it.
So, if the brain isn't a Turing machine, then what on earth is it? And that question is what leads us right to the heart of this explainer, the relativistic brain theory and a totally new way of looking at the mind.
At its core, the theory says the brain is something called a hybrid digital analog computational engine. Yeah, it's a mouthful, so let's just call it HDAC. What this means is that your brain isn't just one kind of computer. It's actually using two completely different styles of computation simultaneously all the time.
So this HDAC model has two T parts. The first part is the digital one, the one we all know about. It's the firing of individual neurons. You can think of those as the brain's bits. But then there's a second part, the analog component. And this is the secret ingredient, the real game changer here. It's these subtle but incredibly powerful things called neural electromagnetic fields, or NEFs.
So where do these NEMs come from? Well, they're generated by the flow of electricity through your brain's white matter. And that white matter, it acts like a giant tangled network of biological wiring, almost like little coils. And according to this theory, it's the constant humming and interaction of all these fields that creates an internal analog mental space. And get this, that space is supposedly the very fabric of our thoughts, our feelings, our entire unified sense of self.
This idea of a mental space is huge because it completely flips our understanding of what information even is.
Okay, so a computer deals with what the theory calls type I information. This is stuff from the outside world, it's digital, it's based on syntax. Think about the data you'd get from an EEG machine or just lines of computer code. But the brain also creates and deals with type 2 information. And this stuff is totally different. It's internal, it's analog, it's semantic. This is our subjective experience, what it feels like to be you, your sense of self, the actual sensation of pain. It's information that has meaning baked right into it.
Just think about the classic example of phantom limbs. You can have someone who says this exact phrase, who knows perfectly well their arm is gone, but can feel their fingers clenching. That feeling, that's type 2 information. It's being generated from inside the brain's mental space, and it completely contradicts the reality of the outside world. A computer, which only works with external data, could never, ever compute that kind of contradiction.
So this internal body image isn't just some data file stored away in a folder. No, it's an active, constantly updated analog thing that's being created inside that mental space. And this idea neatly explains not just phantom limbs, but also those crazy experiments like the rubber hand illusion, where your brain can be tricked into feeling like a rubber hand is your own. Why? Because it's trying to fit it into its internal analog model of you.
All of this hybrid digital analog model, it puts the brain into a completely different league. It's way, way beyond any Turing machine we know how to build.
So what does this all mean? It means the brain isn't just sitting there passively waiting for data to come in from your eyes and ears. No, it's actively creating its own point of view. It's generating expectations and making guesses about the world before the sensory information even gets there. Your brain isn't a processor, it's a prediction machine.
And that right there shows you the fundamental gap in what they can do. A Turing machine, a computer, is an amazing tool for solving problems that can be computed. But the human brain, with this hybrid engine, it seems to be in a class of its own, uniquely built to tackle those non-computable and intractable problems that make a normal computer just throw up its hands. This actually leads us to a whole new classification of device, a hypercomputer. A hypercomputer is any device, whether it's just a theory or, a biological one, that can do things a regular Turing machine simply can't. And what the relativistic brain theory is really saying is that the human brain might just be the first and most powerful example of a hypercomputer we've ever found.
So when you boil it all down, it means your brain isn't a machine that was built from some neat blueprint. It's a messy, integrated, evolved system. It's the product of a ridiculously long history of random chances and adaptation. And here's the kicker, you can't reverse engineer something that was never engineered to begin with.
And that leaves us with a pretty mind-bending final thought to chew on. If our minds aren't just algorithms, if our consciousness isn't just some super complex program running on meaty hardware, then what does that really mean for the future of artificial intelligence? And maybe more importantly, what does it say about the profound and maybe even irreplaceable uniqueness of being human?